And like, you should just be video recording me. I don't have release forms for any of the rest of y'all and that kind of thing.
Okay.
But, hello. This is Miss Bender, and we're doing the parts of your heart for your cardiovascular system. For my lecture class, this is your heart objectives 1, 4, and 5. That would be location of the heart in your body, the different chambers and their purposes and what they do, as well as the vessels that are attached to them and the path of blood flow through your heart. I normally do this by drawing for you guys on the dry erase board, so I'm just filming myself doing that for y'all now. If you're watching this for lab, you guys will have an additional lab video of me just pointing out the parts on our heart models as well. But both of the information you have to be able to point to and label everything, so this is important for everybody to know. Okay. Normally, when we're doing this in class, I encourage y'all to draw along with it, because that will help everybody understand. So I do 2 versions of this for everybody, because everybody can follow along. Okay. Simple stick figure. We're going to start with the box. Okay. And then I'm going to do a slightly weirder anatomically correct one. Okay. I know it looks goofy right now, but bear with me. Okay. So, the heart, its job is to perpetually and continuously pump blood all day, every day. It's going to go off at least 1 time a minute, right? Its job is to get blood from itself to the lungs, then have the blood go back to the heart, and then everywhere in your body, including your tippy toes and everywhere else. So it has to beat persistently, consistently, and there has to be a direction of blood flow, right? You don't just get to like squish a water balloon on the inside and have blood flow in all the right directions. That's actually how insects and bugs work, and you guys know what happens when you step on a bug. Right? So we have to ensure that our blood flows in one direction through our entire body, the right way through the pipes, which are arteries and veins, and that's the job of your heart to direct it. Right? So your heart is divided into 4 chambers. Okay? So for my stick figure beeps, we're just going to divide into quadrants. They look a little bit weirder on your full-size heart because they are not all the same size. So you have 2 top ones and 2 bottom ones, and you always have a right side and a left side, right? For those of you that need a refresher from Anatomy 1 and 2, or Anatomy 1 because this is Anatomy 2, when we're labeling things, we always label the patient's body, not ours. So if I am staring at a patient in front of me who's facing me, or if I have a patient that's lying on a surgical table in front of me, this is their right side. And this side is their left side. Right? Because remember, like if I'm facing you, this is my right hand, but your right hand is over there. And this is my left hand, but that's yours. So we label the patient's anatomy, not your sides. Right? So the top chambers are called the atria. If you want to only refer to one of them, it's called an atrium. It's one of those weird Latin words where the plural ends in an A instead of an X. Right? So the tops are called atria. The bottom two are called ventricles. So you have a right ventricle and a left ventricle. The jobs of the top two and the jobs of the bottom two are different. And the job of the left side versus the right side are also different. So first things first, we are going to talk about the jobs of your atria. Your atria is supposed to collect or accept the blood. Okay? So whenever blood is on its way back to your heart, the first place it is going to reach are one of your two atria. Okay? Your ventricle's job is to pump the blood where it needs to go. So the job of the top two chambers are to collect the blood and get it all for you. Job of the bottom two chambers is to pump it where it needs to be. Just by knowing that, which one do you think is going to have stronger muscles around it? The top or the bottom?
The bottom.
The bottom, right? Because the top is just collecting it, but the bottom has to pump it all the way to your toes or anywhere else. So the muscles around the bottom are going to be thicker. Okay? So we know that right off the bat. And that brings us to the left and right sides. Okay? The right side's job. Okay? It collects deoxygenated blood, meaning it is dealing with the used blood from your body that does not have oxygen, because that blood has already given its oxygen to the rest of your cells. So our starting point is cleaning our used dirty blood, basically. Right? It's not your heart's job to clean it and to exchange waste for nutrients or carbon dioxide for oxygen, but it's your heart's job to get it there, right? So the right side of your heart is going to collect deoxygenated blood. That means it is used blood with waste products in it. So it is going to collect, so the job of your right atrium here is to collect from your body So it's sitting here, getting all the blood from you. And there are two major blood vessels that dump this blood back into you, or back into the heart. They are called your superior vena cava and your inferior vena cava. So as I'm labeling this stuff on this side, this is like the anatomical one, I'm going to spell it out a little bit. So we have from the top, superior, which means above, right? So you have your superior vena cava. Your heart's right about here. All the blood that is coming back to your heart from your head or above your heart, right? From your arms, it's heading back down through that vena cava, or superior vena cava. And then you have the lower one, which is inferior, right? That was your anatomical term for below. So everything, all the blood that's coming back to your heart from below your heart is coming back from your inferior vena cava. All this blood is going to happily come back into your heart, into your right atrium. But your heart can't let things go backwards, right? Your blood has to go in one direction. That means there has to be a doorway right here between top and bottom. One's being collected, and then the blood is going to flow downwards so it can get where it needs to be, right? So there has to be a doorway here that prevents it from going other places. The doorway on your right side is called your tricuspid valve. It's a valve and it opens and closes. Right? And it prevents blood from going backwards. So your tricuspid valve is going to prevent the blood from flowing backwards. It's called your tricuspid valve, and you guys will see this on the models, because when you're looking at it from like down below in the heart, it looks like a little peace sign. It has 3 little flaps to it. So it has 3 cusps, or 3 little flaps. That's why it's the tricuspid valve. Tri means 3, like a tricycle has 3 wheels. So your tricuspid valve is on the right side. The blood has to flow through there once it's been collected in your atria. And then it gets into this right ventricle. So all this deoxygenated blood flows down past your tricuspid valve into your right ventricle. So the right ventricle's job is to get blood to the lungs. Get blood to lungs. Because your lungs are what trade the carbon dioxide for the oxygen. We'll get into that more in lecture for like the how that happens. But the lungs' job is to trade oxygen for carbon dioxide, so the waste in you for the energy you need to keep going. So the job of your right ventricle is to get blood to your lungs. And if we look on our models and we remember from our other anatomy, the heart's here, kind of in the middle, but still on the left side a little bit, but you have lungs surrounding your heart. So that blood doesn't really have to travel very far. Right? You have a big blood vessel that comes up from here, and then splits to your right and left lungs. That is called your pulmonary trunk. If you see the word pulmonary, or pulmonary, pulmo, something like that, That's in reference to your lungs. So your pulmonary trunk is where this deoxygenated dirty blood ends up coming, splashes down in here, and then it eventually ends up being pumped back up the pulmonary trunk. And your pulmonary trunk splits into a right and left pulmonary artery. This is the left side. Okay, so your pulmonary trunk is where the right ventricle is going to pump the blood to, and then the pulmonary trunk splits to send the blood to the left or the right lungs. And it's going to send that blood through the pulmonary arteries. So you have a left and a right one. I'm not going to draw the lungs right now, because that's an entirely different unit and we aren't there yet. I'm just kind of going to draw balloons, right? Because y'all know what balloons do. They have air in them, and so do your lungs. Right? So those are your lungs. There you go. On our little shorthand version here. I'll label that over here. Pulmonary trunk. And right, left. Pulmonary arteries. Let's then go to our little balloon lungs. Okay. So that's what happens to the deoxygenated blood that needs to exchange the oxygen for carbon dioxide, right? This is deoxygenated, so this blood does not have any oxygen that's good for you, right? And this got to the lungs. Right. Huzzah! We're good on that. Okay. But now blood has to come back to the heart to get to the new places that it's going. Right. So coming back from the lungs, into, once again, the left atrium, because now we're on the left side of the heart. And yes, you do have a couple of these. There's a top and bottom one. Those are your pulmonary veins. So you have left pulmonary veins, which bring blood from the left lung back to your left atrium. And you have right pulmonary veins. That bring blood from your right lung back to the left atrium. And this is your left atrium. Okay. The job of your left atrium is to accept oxygenated blood from the lungs. The whole job of your left side now is going to be to get oxygenated blood around the body. Right, so the job of the left side of the heart is to get oxygenated blood around your entire body. So at this point, we have oxygenated blood from your lungs coming into your left atrium, and then once your left atrium is full, all of that blood is going to be pumped down into your left ventricle. But just like before, you have to have a door there. You have another valve because you can't let blood backflow from your heart back into, like, you can't have blood go from your ventricle back up into your atrium and risk it flowing back into your lungs. That would be super, super bad if that happens, right? So you have another valve there. You have another doorway that prevents this. This valve has two names. Y'all, like, the two names are interchangeable. I'll put it that way. Your lab list has one of them parentheses the other one, right? I don't care which one y'all put down on your quiz or your midterm, as long as you know them. Typically speaking, like, the two names are interchangeable. You'll see both of the names in lecture as well. This valve over here, when you're looking down on it, it only has two cusps, or two flaps on it, right? So its fancy term is the bicuspid valve, because bi means two, like a bicycle has two wheels. So you have two cusps on your bicuspid valve, right? But that tends to lean toward, like, everybody knows what you're talking about when you say bicuspid valve. Normally when you're talking to a patient, the doctor will call it your mitral valve, right? They are the exact same thing. I will accept either of the two of them as the correct answers on y'all's midterms and quizzes. So as long as you, if I say, like, what is this valve, and you write bicuspid valve, congratulations, you are correct. If I say, what's this valve, and you tell me it's the mitral valve, they still got it right. They are the same thing. It's just, it has two different names for whatever reason, and for whatever reason, medical professionals tend to, like, refer to it as mitral valve to, like, the normal people and laymen and their patients, but between each other, they'll refer to it as bicuspid. Like, whatever works.
Does the tricuspid valve have two names? Does the tricuspid valve have two names?
Tricuspid does not have two names. It's just the tricuspid. For whatever reason, it's just the tricuspid. Okay. So this valve that prevents backflow on the left side of your heart has two names, and it can either be called the mitral valve or bicuspid valve. Whichever one you want to remember. I don't care either way. Like, that's up to y'all. For some people, it's easier to remember mitral valve because the mitral valve has more problems with it as you get older. We'll get into that in just a second. And you might have had a grandpa or a dad whose mitral valve needed to be replaced or something, and that kind of brings it home and makes it easier to remember. Other people, you may be panicking during your midterm, the world may be crashing down, and then, oh no, wait, which valve is this? I don't want to get confused. Wait, I can count the cusps on the little flaps on the models. One of them has 2 and the other one has 3. I know what to name it now, because you can literally like flick the 2 different cusps, because one of them has 2 cusps and the other one has 3 cusps. And if you can remember that, you know that the one with 3 is the tricuspid, the one with 2 is the bicuspid. Whichever way. Like, however you remember this, as long as you remember it, you're good. Right? But your mitral bicuspid valve is that doorway right there. Okay. And then the blood goes down to your left ventricle here. Okay. And then it has to go to the rest of your body. It has to get from this chamber of your heart everywhere from next door to actually feeding itself, because the heart has to have its own system to feed itself with a circulatory system, and it has to feed the lungs itself, or get that blood all the way down to your tippy toes, right? It has to get the blood everywhere. So you have a giant artery that comes in from this corner of your left ventricle. It tucks up underneath your pulmonary trunk. But you know this giant artery. And all of your blood goes from your left ventricle through the aorta, which is the name of the biggest artery in your body. And it goes from your aorta everywhere else in your body. So on this little picture here, I'm now going to draw, I'm going to draw it out the incorrect side, but that's your aorta, and it's going to get the blood to the rest of your body. So this is a 14-step long process. There are 2 more doorways we need to contemplate and consider. And also a little bit more structure. Out of all 4 of these chambers of your heart, which one do y'all think is going to be the biggest that has the most muscle?
The left ventricle.
Left ventricle. The left ventricle is always going to have the most muscle around it, because this guy has to get blood all the way down to your toes and back. Your left ventricle has the most muscle and beats the hardest. Right? So your left ventricle gets the blood to body as its job. Right? That's its job. That's what it does. But that means because it has to pump the strongest, this valve takes the brunt of the damage because it's preventing the backflow. So usually with our older individuals, because your heart's beating from the 2nd trimester of pregnancy until the day you die, once a second at least, right? This valve has taken a beating by the time you are 80 years old. So after a while, if you are going to get valve problems, it is more than likely going to be this mitral valve here. Because it happens to be on the left side and it's the door or the valve that's taking the brunt of the damage. Probably why that's the one that has 2 names and the other 3 don't. So the left ventricle is the largest one and has to beat the hardest because it's the one that has to get the blood the furthest, right? Your atria are just collecting the blood, and your right ventricle just sends the blood next door to the lungs. But your left ventricle has to get it all the way down to your toes. You have two other valves to prevent blood from backflowing. So two other doorways. Both of these valves are collectively known as the semilunar valves because their valve is kind of shaped like a crescent moon. These valves, you have one right here at the base of the pulmonary trunk, which is called the pulmonary valve, to prevent blood from going from lungs back to the heart. And then you have a valve right here on the aorta. And that valve is called the aortic valve because it prevents blood from going from your aorta back into your left ventricle. And your aorta, I might add, if I'm drawing another little picture for y'all. So you have your heart pumping here. Your aorta is absolutely huge. It actively leaves your heart, goes up and over and around, and then down behind it. So your aorta, when we get to your blood vessels, is actually broken up into different parts where you have the aortic arch, the ascending, because the blood is going up, and the descending aorta, because the blood is going down at that point. So your aorta is big. You don't want blood backtracking through there, right? So you have that nice little aortic valve to prevent that. Right? Both the aortic valve and the pulmonary valve are semilunar valves, so they both have the same shape. For the purposes of y'all's class, y'all's lab list calls them the pulmonary valve and the aortic valve. You may see them in lecture as written as the aortic semilunar valve or the pulmonary semilunar valve. Same thing. One of them is just more wordy and descriptive than the other. Y'all can remember the shorter version of that. It's the same thing, right? So y'all will be good. Let's see. So I believe that is the most of everything.